Hi with math is easy with Ala. Continue with calculus 2, vectors 10.3, the dot product. How can we compute A dot B in two dimension if A equal 2 and 5 and B 4 and negative 3? We know that in two dimension A dot B, if A equal A1, A2 and B equal B1, B2, then the dot product A dot B is a scalar and it's equal to A1 times P1 plus A2 times B2. So A dot B equal 2 times 4. 2 times 4 plus 5 times negative 3. 5 times negative 3 and it's equal to 8 minus 15 equal negative 7. In three dimension, we use the same strategy. A dot B equal 1 times 5 plus 3 times negative 3 plus negative 2 times 1. And 1 times 5 is 5. 3 times negative 3 is negative 9. Negative 2 times 1, negative 2. 5 minus 9 minus 4 minus 2 is equal to minus 6. Sometimes it's coming like this, and it's same when I want to find A. A is equal to 3 and negative 4. B equal to 2 and 6. So A dot B equal 3 times 2. 3 times 2 plus negative 4 times 6. And it's equal to 6 minus 24 and it's equal negative 18. Fourth example, same, A equal 3, negative 4 and 1. B equal 2, 6 and negative 3. So A dot B equal 3 times 2 plus negative 4 times 6 plus 1 times negative 3. 3 times 2 is 6 and negative 4 times 6 is negative 24. 1 times negative 3 it's negative 3. Negative 6 minus 24 it will be negative 18 minus 3 negative 21. How can we find the angle between two vectors? We know that A dot B equal the magnitude of A times the magnitude of B times cosine theta. So cosine theta equal to A dot B over the magnitude of A times the magnitude of B. For that, theta equal cosine inverse A dot B over the magnitude of A times the magnitude of B. What we will do here, first of all, we will find the magnitude of A. The magnitude of A equal 3 squared plus negative 4 squared. And it's equal to 9 plus 16 equal 5. So the magnitude of B equal 1 squared plus 2 squared. It will be 1 times 2 it will be 1 squared 1, and 2 squared 4, it will be radical 5. After that, we find a dot b, and we know that a dot b 3 times 1, 3 times 1, because this is 3 and negative 4, and this is 1 and 2, plus negative 4 times 2. It will be 3 minus 8, it will be minus 5. So now theta equal the cosine inverse of a dot b negative 5 over the magnitude of a 5 times the magnitude of b radical 5. And if you have the calculator, let's take the calculator. Let's find the calculator. Just a minute, let me bring the calculator. The calculator. This is the calculator. What we will do here, this is our calculator. Menu 1. Okay. Shift cosine fraction negative 5 over 5 times radical 5. And this is equal to 116, around 116.6. It equal 116.6. Also, we can find it by the calculator. Let's see how can we do it. This is the calculator. I will go to menu, then I will go to vectors here. Then I will choose the vector 1, vector A. The dimension is 2, and I put 3 and negative 4. This is the vector, the first vector. Then I go to option, go to 2 to edit another vector, 2, vector B, and it's same 2 dimension, 1 and 2. Now I will go to option, then I will go here to angle, and I write vector A, option vector A, and I will choose the comma here. Then I go again to option and vector B. Close the brackets, and just a minute, what we did, angle vector A, where is the dot? Okay, shift, we use this one, I think. Yes, this one we will use shift and the brackets here. Same answer. Okay, let's continue with another example. If we have 3 dimension, same step. First of all, we find the magnitude of A. It will be 3 squared plus negative 4 squared plus 1 squared. And it will be 9 plus 16 plus 1. It will be 25, 26. Then the magnitude of B is 2 squared plus 6 squared plus negative 3 squared. and this is equal to 4 plus 36 plus 9. It will be 7. 49, it will be 7. Now, a dot b equal, we multiply 3 by 2, then negative 4 by 6, then 1 by negative 3. It will be 6 minus 24 minus 3 minus 27 minus 21. It will be minus 21. So, theta equal shift cosine a dot b negative 21 over the magnitude of a times the magnitude of b. Same way here, go to menu 1, shift cosine fraction, we will write negative 21 over 7 times radical 26, sorry. It will be 126, around 126 approximately. How can you use the calculator? Go to menu, go to vectors, then choose vector 1, 3 dimension, 3, negative 4 and 1. 3, negative 4 and 1. After that we go to option, we choose edit to edit the second vector, 3 dimension, 2, 6 and negative 3. We finished now. Now go to option, down to angle, then go to option. The first vector is A, number 3. Then choose shift with the brackets to make the comma. Then choose the other vector 4. Same answer, 126.039, approximately 126. Now, how can we determine whether the vectors are orthogonal or no? If they are orthogonal, then the angle between them is 90. And cosine 90 is 0. So A dot B will be 0, because the magnitude of A times the magnitude of B times cosine theta. It will be the magnitude A times the magnitude of B times 0, and it will be 0. So if the dot product here is 0, then they are orthogonal. A dot B equal to 2 times 2 plus negative 1 times 4. It will be 4 minus 4 equals 0. So the vector A and the vector B are perpendicular or orthogonal. Same here, A here, but you want to know that 3, 0 and 0. B is 0, 6 and negative 2. So A dot B equal 3 times 0 plus 0 times 6 plus 0 times negative 2. So it will be 0. So the vector A and vector B are orthogonal. If another example, if we take like third example, if A equal 3 and 4, B equal 2 and 1, then the vector A dot B equal 3 times 2 plus 4 times 1. It will be 6 plus 4. It will be 10. and this does not equal to 0, so A and B are not orthogonal. Find the vector of the form A 2 and negative 3 that perpendicular to 2, negative 1 and 0. Same way, what we will do, we multiply the first vector by the second vector. A times 2 plus 2 times negative 1 plus negative 3 times 0 equal 2A minus 2 minus 3, and this must be equal 0 because they are perpendicular. The angle between them is 0. So 2A minus 5 equals 0. Remove 5 to the other side. It will be 2A equal 5 by adding 5 to both sides. Then divide by 2. It will be A equal 5 over 2. Then the value that make these two vectors, the value of A that makes to these vectors perpendicular is 5 over 2. Now, what is the component of A along B? This is we call component of A along B, and the projection of A onto P. Now, the component, this is the first one. How can we find it? The component of A, component of A along P equal the, A dot B over the magnitude of A, or the magnitude of, here will be, write it, okay, the magnitude of B. So what we will do first, we multiply A times B, it will be 2 times 3 plus 1 times 4, this is the first step. It will be 6 plus 4, it will be 10. After that, we find the magnitude of A if B. So the magnitude of B equal 3 squared plus 4 squared. So it will be 9 plus 16, and it is equal to 25. To radical 25 is equal 5. Now the component of A long P equal A dot B equal 10 over the magnitude of P equal 5, so it will be 2. But the projection of A onto P equal A dot B over the magnitude of P squared times vector B. So what we will do, we have A dot B. We know that A dot B equal 10 and the magnitude of P equal 5. So what we will do, we will put the formula the projection of A onto P equal A dot B 10 over 5 squared, the magnitude, times the vector B, 3 and 4. So this will be 10 over 25 times 3 and 4. 10 over 25, it's 2 over 5. Multiplied by 3 and 4, we multiply 2 and 5 by 3 and 2 over 5 by 4. It will be 6 over 5 and 8 over 5. Also here we can use another formula to find the projection of A onto P equal the component of A long B, the component of A long B, because the component of A long B equal A dot B over B. So times the unit vector of p, p over the magnitude of p. And this is also, we found this one, it will be, the component is 2 times p 3 and 4 over the magnitude is 5. So it will be same 2 over 5 times 3 for the vector p. So 2 over 5 times 3, it will be 6 over 5. And 2 over 5 times 4, it will be 8 over 5. Now, the same way, I'm sorry, if we have 3 dimension, first of all, the component, we know that the component of along P equal A dot B over the magnitude of B. So first of all, we find A dot B means 2 times 0 plus 0 times negative 3 plus 2 times 4. And it will be 8 because 2 times 0, 0, 0 times negative 3, 0, 2 times 4, 8. And the magnitude of B will be 0 squared plus negative 3 squared plus 4 squared. This is the second step. And it will be 0 plus 9 plus 16, and it's equal 25, radical 25, and it's equal to 5. Then the component A along P equal A dot B equal 8 over the magnitude of P equal 5. Now, the projection A onto P equal A dot B over the magnitude of P squared times B. And it's equal A dot B, we know that A dot B 8, and the magnitude of P is 5 squared times 0, negative 3, and 4. And this is equal to 8 over 25 times 0, negative 3, and 4. So it's equal 8 over 25 times 0, 0. 8 over 25 times negative 3 minus 24 over 25. And 4 times 8 over 25, it will be 32 over 25. And same way, if you want to find it, use the component. The projection of A onto P equal the component of A along B times the unit vector of B. So the component, we found it 8 over 5 times B, it's 0, negative 3, and 4 over the magnitude of B is 5. So it will be same 8 over 25 times 0, negative 3, and 4. And when you multiply them, it will be the same answer because 8 over 25 is 0 times 0 is 0, and 8 over 25 times negative 3, it will be negative 24 over 25. And 8 over 25 times 4, it will be 32 over 25. So this is how can we find the component and the projection. Thank you, and please don't forget to subscribe to channel. See you in another video.